Hi, everybody. I'm in the week number 2 lecture assignment on chemistry. And when I clicked on that assignment, I went to the reading, and after that, you'll go to the questions. I'm going through this based on the lecture study guide for week number 2 chemistry. So the highlighted areas are areas that you should concentrate on, but there can be information outside of that that will be useful to you too. So I'm just going to quickly go through sections 2.1 and 2.2. In 2.1, it asks you about to distinguish between atoms, elements, and molecules. And what you can do is you can just listen to this and then go review it in your book yourself and take your notes, or you can stop this video periodically and write notes. But I'm probably going to talk a little bit faster than what you would need to, that I would do in class where you're taking notes at the same time. So pause this video at any time if needed. What you can see is an element is one of the basic building blocks of matter. It can't be broken down by chemical means. On here it tells you that there's 98 naturally occurring elements, and really just about most of living organisms are composed of 4 of those elements: carbon, nitrogen, oxygen, and hydrogen. And you're going to see those more this semester, in fact, in this series of lecture this week. You are probably familiar with the concept of the periodic table, where there are symbols for each element, and so some of these kind of look familiar: carbon, nitrogen, oxygen, neon, all sorts of kind of things. And there's a lot of information, like I said, that we're not covering. We just can't possibly cover everything in the book, but feel free to read these sections. An atom is the smallest unit of an element. So 1 unit of an element is an atom. So you can put these atoms together, and we're going to talk about in a minute, to make molecules. You've probably learned it somewhere that atoms are composed of proteins, neutrons, and electrons. I'm not going to spend a lot of time on that. You don't have to draw the structure of an atom, but be aware that those are the major parts. One of the tricks to knowing what I need you to know is look at that vocabulary list on your lecture guide. I have matter, elements, atoms, molecules. I don't have protons, neutrons, and electrons, but it would be good to recognize that those are parts of an atom. You don't need to know much more than that, though. The last thing that I wanted to touch on was just what is a molecule. So we've got an element and an atom, and so the molecules, I'm going to scooch down here, are atoms that are bonded together into molecules. So more than one atom. What we know is that the electrons interact between atoms and allow atoms to connect to each other into molecules. And some molecules just have 2 atoms. Other molecules can have hundreds of atoms. And so we're going to be looking at some various molecules in this chemistry unit. You've probably learned about different kinds of chemical bonds, and again, those aren't in your list, so you don't need to know the different kinds of bonds. And I'm going to skip forward. In fact, the other thing you're going to see is at the end of each section, there's a check your progress. On your lab study guide, if you need to be able to answer any of these questions, I will write it on there. But you'll notice after section 2.1, I don't have any information. I don't have a check your progress there. So all of these questions are outside of the scope of what we are doing. So I'm going to move on to section 2.2. Notice you can use these little arrows there. In section 2.2 in your lecture study guide, all I've asked you to know is to talk about the pH scale and the characteristics of acids, bases, and what are buffers. So I'm going to go down here. There's a lot of interesting stuff about water, but in the interest of time, I'm going right to pH. So here we talk about the pH scale. Actually, right above that, it's talking a little bit about, what are acids and bases. And when water molecules break up, they release an equal number of hydrogen ions and hydroxide ions. And they're showing you this picture here. And so water is actually neutral because it releases the same amount of hydrogen ions and hydroxide ions. But Solutions that release more hydrogen ions are acidic, like hydrochloric acid, and solutions that release more hydroxide ions, OHs, are bases like sodium hydroxide. So if we look down here at the pH scale, it says the pH scale is used to indicate acidity or basicity, also called alkalinity, of the solution. The pH scale goes from 0 to 14. And so it tells you here that a pH of 7 is neutral, where hydrogen ion and hydroxide ion concentrations are equal. So again, we go back to water, and one water molecule, one H2O, can dissociate into an H plus and an OH minus. So there's an equal number of these hydrogen and hydroxide ions, and they will, that causes the solution to be neutral. A pH below 7 is acidic, and because there's more, the amount pH 7 acidic because the hydrogen ion concentration is greater than the hydroxide ion concentration. There's more H pluses. pH 7 above pH 7 is basic because there's more OHs. Now, if we look a little bit, that's kind of the real chemistry definition of acids and bases. But the other thing you know about acids, so acids have a lower pH, have a pH less than 7. They're also sour if you taste them. Not all acids are safe to taste, but those that we do, they taste sour. And pHs above 7 are basic, more hydroxide ions, and those solutions tend to taste bitter. And you can probably look at this pH scale and notice that there's a lot more things that we eat that are sour. We have lemon juice, vinegar, cola, tomatoes, coffee. All these things are in the acidic ranges, and we prefer those sour flavors much more than we prefer bitter flavors. Notice there's like almost nothing. Oh, we eat baking soda. I heard that egg whites have a little bit of an alkaline or a little bit of basic pH, but there's not very many things that we like that are bitter, and so we just have prefer the sour flavors over the bitter. The other thing kind of weird about bases is they're slippery. If you ever put ammonia in your hands, or bleach is actually basic, and you can feel it's really slippery. That's another characteristic of bases. So the bottom line, the pH scale goes from 0 to 14. 7 is neutral, below 7 is acidic, above 7 to 14 is basic. And the last thing I wanted to talk about, another important thing about the pH scale is that from each number in the pH scale, you get a 10 times difference. So pH 7, pure water, to pH 6, where urine typically is 10 times more acidic. So urine is at least 10 times more acidic than water. If we go to black coffee, we go from 10 to 100. So coffee is 100 times more acidic than water. And if we go to tomatoes, we've got 10, 100, 1,000. Tomatoes are 1,000 times more acidic than water. And it goes the other way. Seawater is 10 times more basic than pure water, and et cetera, et cetera. The last concept I wanted to touch on is the concept of a buffer. And it tells you here that buffers prevent pH changes. Now, most of the time when we're talking about the human body pH is around 7.4. It says it right here. The pH of our blood and of our other body fluids, most of our body, internal body fluids, pH is around 7.4. And so what we do is we have chemicals called buffers that are in solution in our blood and other body fluids that hold the pH to 7.4. And hopefully I'm going to convince you that it's really important that the pH of your body stays consistent, that it doesn't change too much beyond that pH 7.4. Now, if there's a buffer in our stomach acid, which is, obviously acid, it's going to hold the pH closer to pH 2. So different buffers hold the pH at certain ranges. A lot of people say, oh, buffers hold the pH neutral, but they don't. It just happens to be that our bodies are close to neutral. They hold pH at a constant value. So different buffers for different situations. So buffers hold the pH at a constant value, and that's going to be important for normal metabolism. You'll notice on your handout, I said check your progress. You should be able to answer questions 2 and 3, and notice that they give you the answers if you click on those. And then when you've studied this section and you're done on this and all the other sections, then you can go to the questions for which you get credit. These are not the questions you get credit for. These are the questions that are just practice. Okay, take care.